Okay, hi everyone. I'm Alex. I'm originally from Germany, so you might hear some German accent every now and then. But as we just said, I'm currently a second-year PhD student at the mathematics department here at King's College. So I started my PhD 1.5 years ago, and I still have 2.5 years to go. So I'm literally just right in the middle of it. And yeah, before the main talk, I'd like to give you essentially I'd like to share with you my path from school to the PhD. And I hope that by doing that, I'll also help you in getting a clearer idea and a less abstract idea of what your future might look like beyond school. Okay, so essentially my academic journey, like all of them essentially, I guess, started with a very big question, right? It was sort of, what's next? So I knew I wanted to go to university. I didn't really know what I wanted to study though. And this was kind of overwhelming because there are so many options out there. And in the end, obviously, you should make the choice yourself. So in my case, I decided to go just to follow my own interests. So my first plan was actually to do astrophysics. So maybe that's a bit of a surprise for you because right now I'm obviously in the math department. But back then, studying maths, it did not even cross my mind, to be honest. I enjoyed maths at school, but I had no clear vision of what a career in math could look like. And also, it didn't cause a big spark in me, I guess. But what definitely did excite me was understanding the universe and how stars are being born and how we can understand the distance from us. And just how we know that the universe is expanding, for example. So I thought, why don't I just study astrophysics? And then after speaking to a teacher of mine, essentially, he advised me to take a broader approach. So instead of studying just pure astrophysics, he said, go for something more general that allows you to keep all your options open. So eventually, that meant for me to study physics. So my journey started with a BSc in physics with an astrophysics focus, actually, and that was in Switzerland. So in this program, 2/3 were physics modules, and 1/3 was split between astrophysics and maths, actually. And after a few months, I realized two things. So first, I didn't enjoy astrophysics as much as I thought I would. Mostly because there was a lot of heavy and mandatory reading each week, and that felt for me a bit more like a core than something that actually enhanced my knowledge. That was one thing that I learned quickly. The other thing that I learned was that physics is not just physics. First I started to question my astrophysics choice. That was one thing. And the other thing was, physics is really many things. This was something that I was not aware of before entering university. But as soon as I was there, my curriculum, it covered a very wide range of subfields, and each of them came with its own philosophy, perspective, approach, questions, and challenges. And the same is, as you might already know, it's also true for maths, right? So studying maths, it does not mean studying one thing. Instead, it's an entire world of different kinds of maths. So I found this variety very fascinating, and I wanted to explore more. So luckily, I could switch my focus back then, and I dropped astrophysics, and I decided to focus on maths furthermore. Specifically to make things maybe a little bit less abstract, I had the following modules here in my BSc. So the main core programs or modules were linear algebra and analysis. So linear algebra, you talk about vectors and matrices and also geometric transformations, right? But also you think about how to solve systems of linear equations efficiently. And analysis, it builds the foundation. You build in that lecture the foundations of calculus, essentially. Talk about integration, differentiability, limits, continuity. So that's all very, very important fundamental things. And then furthermore, I chose complex analysis, probability and combinatorics, differential geometry, algebra, and statistics. So this was actually a very small selection of subjects, but also looking at it now, it was very unfocused. But I think at this time back then, I really didn't know where I was heading. I was just trying out different things. And now I'm really happy that I did that. Because I realized that pure math, such as algebra, it wasn't really the right fit for me. But I really enjoyed like concepts and modules that allowed me to obtain some more quantitative problem-solving skills, perhaps, for which I, in that moment, saw some practical applications. So, yeah, essentially, also in my physics course, I was surprised because from all the classes that I had, solid-state physics, optics, particle physics, quantum theory, the one I liked most was a coding class. I had never done coding before university. I would have never thought that I could enjoy it. But as soon as somebody explained to me what a compiler was, how to program in C, how to approximate integrals, how to solve differential equations, like you name it, I was excited about it. So yeah, somehow my bachelor's, my undergrad was definitely full of surprises for me. And then afterwards, I went for an MSc. So in that, I kind of, again, tried to just incorporate my interests, and I tried to find a degree that combined this new curiosity for computational methods, but also this idea of I really want to obtain quantitative problem-solving skills, as I've seen them in my math modules. So then I heard about an MSc in Computational and Applied Mathematics. That was in Germany, and yeah, this curriculum essentially exactly covered what I was interested in back then. So it taught me, or I could improve my coding skills, but it also taught me how to derive and analyze mathematical models, such as used in fluid dynamics or in image processing even. And also I learned how to derive and analyze numerical implementations of these methods. So with this, at some point, obviously, I had completed all my taught courses, and I was, again, at this point in life where I'm like, okay, what's next? I thought, should I go into a finance company, engineering company, insurance, machine learning? Should I start teaching? Or should I pursue a research degree, a PhD? So I spoke to many people around me, and their advice pointed me towards doing a PhD, and I'm very happy that I followed their advice, as this eventually led me to also King's College, which is a really nice place to study at, very welcoming. So now moving on to my current research. So to give you a bit of an idea, my research, it revolves around accelerating sampling methods. So you might have encountered sampling when it comes to population surveys, such as estimating the public opinion on climate change. Since it's very impractical to ask everyone what they are thinking, to ask everyone on their opinion, we select or sample like a small limited number of people, and we use their responses to estimate the answers of the whole population. So another context in which sampling is used that I'd like to mention on a high level and mostly for illustrative purposes comes from molecular sciences. So imagine you have a molecule, so a collection of atoms, and you want to explore the different ways that these atoms can arrange themselves. And this essentially is connected to the question how the molecule behaves or is expected to behave in chemical interactions. So as you can imagine, there are many configurations possible, and the question is which one is the one that's most likely, right? Or which ones are the more likely ones. So there's a key principle essentially that the higher the energy of a state, the less likely it is to find this configuration or this state, and vice versa. The lower the energy of a state, the higher it is to actually find the corresponding configuration. So this is like a guiding principle, I guess. But at the same time, you still need to think about a systematic way of actually constructing the set of possible configurations that follow this principle. So this is essentially where sampling comes in. So on a very high level, you might want to do the following. You start with some initial state, okay, so some initial configuration, arrangement of your atoms, and then you update it. So you take the old state and you adjust it in a way that lowers the energy of the whole molecule, but you'll also add some random rearrangement, some random noise, okay? And this gives you a new state, new configuration. And as it turns out, if you loop over this update rule, so if you repeat it many, many times, And if you repeat the whole procedure for different initializations, then you'll get a set of realistic configurations that the molecule could take. And this essentially will naturally incorporate more low energy configurations and fewer high energy configurations. And this final collection, you can then use it, as I briefly mentioned before, for understanding how the molecule is expected to behave in chemical interactions, so for simulations efficiently. So yeah, that being said, this is more like the bigger picture of applications in which I see my work, while I myself, I'm more interested in, or my work itself, it focuses instead more on theoretical questions. So how can we actually derive and design faster sampling methods? And by fast, I mean accelerated compared to those that are most commonly used right now. So essentially, in the previous slide, I want to change this update rule in order to speed up the whole computation. So exactly. But yeah, so, and this is quite important because the problems we consider, they become more and more complex, the dimensions increase, or they increase from, they keep increasing essentially. So at the same time, our computing power is limited, so it's really important to speed up the computations to still have feasible algorithms. And interestingly, this question, it kind of sits at the intersection of physics, math, and computational methods. So these are all things that I've learned in my studies. So you might think, oh, well, maybe she knows everything. Totally not. Like, I keep learning things every single day. I unlearn things, I relearn things, so the learning journey literally like never ends. With this diagram, I instead want to highlight that there is a significant overlap between these disciplines, right? So you can't just see them as isolated from each other. So this, obviously, once it allows you to transition between study programs and careers at some point, perhaps, but also be aware that when you learn about one of these disciplines, you will always also learn about another field at the same time because there is an overlap. So I think this is kind of like enriching to know as you move forward in your studies. So yeah, that being said, I think I also want to highlight the other research groups that we have at our maths department. So my fellow PhD students, they are in the analysis group, or they study disordered systems, financial maths, geometry, number theory, probability statistics, or theoretical physics. And again, like there's quite an overlap between these groups, but at the same time, all of them are literally a world of their own with their unique approaches, and they definitely offer unique possibilities depending on your interests. So yeah, to wrap everything up, I'd like to leave you with some advice. So I guess that most of you have already decided what to do, what to study at university. If not, also if you have any doubts or any concerns about the road ahead of you, always reach out to people, look for advice, look for different perspectives, but also at the same time make sure that what you choose is always the path that feels right to you. And also, please be aware that as soon as you enter university, so many doors will open. Like, you will learn about subjects that right now you don't even know that they exist. And that's totally fine, that's okay. You don't have to know about them right now. You will hear about them just when the time is right. But because of that, things might not go linear, like in my case, right? Your opinions and interests, they will naturally evolve as you learn more. Maybe they will merge, maybe they will go into very unexpected directions. But yeah, really embrace this kind of change and potential, and yeah, just, I don't know, be excited about the future and everything you will learn at university. And also you will meet very nice people at university, and very inspiring, kind people. So also look forward to meeting them. So that's it from me. If you have any questions, feel free to ask. Other than that, wish you the best of luck on your journeys, and I'm also curious for the main talk.